Hey guys, how is it going? Today we're building the 2048 game using jQuery. And for that we have a new file, and in this file we have a simple 4x4 table with some initial values, and we are set to go. First thing we want to do is include jQuery in our file. So we're just going to include it from Cloudflare, and now we need to go about the logic of the game. So when you press the arrows up, down, left or right, all the board tiles shift until either a numbered tile reaches an edge, or two tiles with the same values are added. So for that we are going to create functions to move left, move right, move up, and move down. But until we want to move the board, we need to know exactly what our board is. So for that we will have a variable that will be current values, and this will be an array. So in order to put values in this array, we'll go through our table, and for each row we will add each table cell in another array. So for each table with the class game, we go through each row and we use the function with the parameters key and value. And here we'll create a new variable, current row, that's going to be an array, and inside each table row we will cycle through the table cells. So each through each table cell in our current row, which is in value, we will go function with the parameters k and v for key and value, and we will put in current row with push, we will put parse integer the text inside v, so inside the current cell. Then we will push the current row in current values. And now we have the entire current values. Now we need a way to know that the key were pressed. So we need to know that the up, down, left and right arrows were pressed, and for that we're going to bind to document the onKeyDown function. So on document dot key down function e, and we're going to use var key code equals e dot key code e dot which, and also we want to define an array arrow that's going to be not array set. And also we want to have a new variable arrow equals left is 37, up is 38, right is 39, and down is 40. These are the keys, the codes for the corresponding arrows. So now we'll have switch on key code, and here we have case arrow dot left, move left, and break, case arrow dot up, move up and break, case arrow dot right, move right, break, and case arrow dot down, move down, break. So now we are going to start creating the actual functions. And let's start with move down. So in order to move down, we need to cycle through all the lines and columns, and whenever we have a 0 and another value above it, we need to shift those values down. And then when we have two values with the same number, we need to add them and shift the added value down. But the rules of the game also say that once an adding was made, the new value cannot be used in the same move. So if we had here 2, 2, 2, 2, it would result in 4 and 4, not just an 8 on the bottom. So first we need to shift the items in the matrix, because this is a matrix, it's a two-dimensional array, so that there are no more zeros on the lower side, except that only if there are only zeros on the column. So for that we are going to go and say we have like 3 steps in this. We have the first step that's going to be removing the zeros. Then we'll have another step that's going to be adding the tiles with same value. And then we'll have adding new tiles to the board on tiles, adding new values to the board on tiles with 0 value. So now that we want to remove the zeros, we will go and say, so we'll go for I variable. I is current values dot length -1. I is greater than 0 and I is decreased on each step. Then we'll go for variable j is current values with the index I dot length. J is greater than 0, length -1, and j is decreased on each turn. So in here we want to shift an element down whenever the current element is 0. And you see that we are going backwards in each array, so we want to go from down to up. So our current element, which is current values with the index a, I and j, is 0. Then for each element that is between I and 0, we're going to shift to the current row, the row above. So if we are on this row and I is going to be 0, 1, 2, for each row above that, we're going to shift them down. So we'll go for k equals I and k greater than 0 and k is decreased each step, then current values k and j equals current values k minus 1 and j. So we're taking the item above and putting it on the item that we're currently on. And after we do that, we want to put on current values 0 and j 0. Okay, so if our current element is 0, all the elements above it are shifted down, and then the top element on that column, so the element on the line 0, will be 0. And that's pretty much it, except for when we have more than 1 zeros, we need to do this several times. And how many times do we need to do it? Well, it will be until there are no more zeros when we have value on a column. But because this is a limited set of repeat events, we will just put all of this in another for, and we'll go for variable t equals 0 t lower than current values dot length t plus plus. So this can mostly be repeated the length of the array. It cannot, this operation will never need to be repeated more times than the length of our array. So now all the tiles were shifted where we need to shift them to the edge of the board. Now we need to add all the tiles with the same value. And the operation is the same, except that we're not going to check for an element if it's 0. Rather, we're going to check if an element is the same as the one above it. So we'll just remove this if statement and replace it with a proper one for adding the tiles with the same values. So if current value I and j equals current value I minus 1 and j. Okay. So we want current value of I and j to become double current values I and j. Right, except that we need to do this and shift everything above. So we will go again for variable So now for adding the tiles with the same value, we need to go through the same process and take the for on the axis for I equals column current values dot length and j current values of I dot length. And we don't need to check if it's 0, rather we need to check if the current element is equal to the element above it. So we need to check if current element of I and j is equal to current element of I minus 1 and j. And if that's so, we need to have current element become current element equals 2 times current element. And also we need to tell the game somehow that this element has been added, so it won't use this value again. So we'll also multiply it by minus 1. So it becomes a negative, and we'll deal with this a little later. But also because we added the elements, we need to shift all the elements above. And for that, we're going to use again this k equals I to 0, k minus minus, except that now we need to go from I minus 1. And also because we are using I minus 1 here, we need to also add the condition that I be greater than 0, and also in order for this not to go into like loops, we need to check that the current values are different than 0. Actually greater than 0, so that the negative values will not be used. So now that we have added the tiles with the same value, we need to deal with the negative values created here. So for that we'll go through the current values again, and we'll use the absolute function that will return the positive value. So current values of I and j is math dot abs current values of I and j. And now we need to add new tiles on the board. In order to add new tiles to the board, we need to know what tiles are set to value 0. So we need to know where 0 is on our board, and for that we'll store the positions of 0 on in a new array called 0 values, and we'll cycle through the matrix again, and whenever we have current values, so if current values I and j is 0, we'll have 0 position, 0 values, equals, no, push a new array formed by I and j. And also we want new values equals 2. So we'll add 2 new values each time. And for the purpose of this game, we're only going to add 2, although the game adds 2 or 4 and adds a random value of each. So now we want to know that we go through 0 values and we add a new. So now we need to add new values until this is positive. Then so we want to add a number equal to new values of new values. So while new values is greater than 0, we will have a new variable that is position of new value is going to be math.floor math.random times zero values dot length. Right, so we want a random number between 0 and the length of 0 values, and this is going to be the index in 0 values where we will add a new value. So current values with the positions 0 values and position of new. Position of new value 0 and position new value 1 will become 2. And we want to remove this index from our array so that it doesn't get chosen again next time. So now we want 0 values dot splice position of new value, and we want to splice the first one, only one. So this could be okay, except that it wouldn't work when 0 values would have a length less than new values. So we need to add a test here, and we'll just say if 0 positions dot length is lower than new values, then new values will become 0 values, not 0 positions, 0 values will become 0 values. And also if 0 values dot length is 0, then the game is lost. So if there are no more empty cells on the board after a move, then the game is lost. So this is pretty much how you move a board. Let's see how it works and if we need to do some debugging. So we're going to refresh, and when we move down, nothing happens. And let's see why. Through the power of video editing, we have debugged the code, and we had some issues here and there. You can see the code updated right now, and also we were forgetting to remove to decrease new values. So now our code is working properly, and in order to make the other directions, we are going to use the same direction, except we're going to use a rotate function, which is a function to rotate the matrix. And this rotate function, basically, if we are moving down, to move left, we will rotate once. To rotate left, we are going to move left, we're going to rotate 3 times, move once down, and then rotate again. So rotate current values 3 times, move down. For right, we are going to rotate once, move down, rotate 2 times. And for up, we are going to rotate twice, move down, and rotate again. And also we want to add our CSS for the colored cells. Basically, all the cells will have a specific set of colors. And the font will increase each time the game score progresses. So okay, so also we need to update the board as soon as the game starts, so that the board starts colored. So let's just go update board. Okay, so there you go. This is the game 2048 made with jQuery. Thanks for tuning in.